Canada. Thank you, Jim. Got it. Across Canada and the Northeastern USA. He is an environmental engineering graduate from the University of Rhode Island and is also fluent in French. Ryan has completed projects focusing on paper cleanup, glass cleanup systems, wood processing systems, and entire plant design in single and dual stream recycling. Having been involved in major projects in Vancouver, Toronto, Montreal, and in all of the largest cities in the Northeast, Ryan's experience is extensive and he's passionate about what he does. Thank you, Ryan. And next, and our third presenter is Patrick Grasso. He's a senior partner at Urban Mining Industries. The company is producing Positive, a sustainable building material derived from post-consumer waste glass. Used as a cement replacement, Positive can reduce the carbon footprint of concrete by up to 40%, while providing a large-scale solution to the ongoing challenges that waste glass creates in our recycling system. Patrick is responsible for ongoing strategic planning, national site selection, capital market efforts, and the coordination of major relationships within the glass recycling industry, developer community, and various government agencies. Patrick's past and professional affiliations and other memberships include the Glass Recycling Coalition. He's a founding and current board member of the Glass Recycling Foundation, the member of the Glass Recycling Committee of the Northeast Recycling Coalition, and the Urban Land Institute, the founding and current board member of the NYU Center for Hospitality. He's earned his MBA from the Wharton School and his BE in Civil Engineering from Manhattan College. So with that, I will turn it over to get started on his presentation. Welcome, everyone. Thank you.
Thank you, Lori. I guess I don't need to make much of an introduction. That was very kind words. I couldn't have written them better myself. So I appreciate you getting us started here. And I think I could just share my screen. Is that correct, Lori, for the presentation? It says it's disabled at this point.
Okay, Jim will handle that, but I'd like to remind folks, please put yourselves on mute. There's some background noise. Sure.
No, they need to.
So, again, folks, are you listening? There is, are you hearing that some background noise? Jim, perhaps you could mute that person. Thank you.
Okay, can everybody hear me and see the screen?
Yes, go right ahead, Frank.
Okay, great. Well, once again, Frank M. Antonacci, Chief Operating Officer at Murphy Road Recycling. And, you know, just a little bit, I think Laura did a great job kind of outlining who we are and you know, how we do things and you know, who we want to be in the marketplace. And I think that something that wasn't in that introduction that I think comes into play later on in this presentation is that we were really proud last year as kind of a real blue-collar workplace to be named one of the best places to work by the Hartford Business Journal through an extensive survey process of our employees. And you know, I think that comes into play on the kind of services we provide and some of the decisions that we make on how we want to do that. And I'll look to circle back to that later on in this presentation on our focus on safety of our employees and our customers. So just to mention that, we're very proud of that accomplishment last year. So our company manages many waste streams throughout Connecticut, Western Massachusetts. And it's not often that we get the opportunity to kind of delve deeper into a specific commodity such as glass to really do a deeper dive. So I'm excited about this opportunity to discuss with all of you kind of, you know, where we were with glass, where we are today, and hopefully where we're going. And I think you have a great group of panelists here to really take that life cycle of glass from the consumer at a store to the curbside collection system into facilities like ours, equipment like Van Dyke, and then to an end product that goes to an in-state facility like Urban Mining. So I think the kind of cadence and order of the presentations here makes sense, and hopefully everybody can take away some things from this presentation that maybe you knew or didn't know, but get some value out of that. I will take a moment to show a clip here. Many of you are in this industry probably have seen our announcements on the All-American MRF that we are building in Berlin, Connecticut, that will be the largest and most advanced system of this kind to process single stream in New England. I won't say much more about it. I'll let the video do the talking, and please excuse the bearded fellow that you'll see.
Building a state-of-the-art recycling facility in Berlin, Connecticut that'll transform the way recyclable materials are processed and sorted for the entire Northeast. We were part of the original infrastructure to service single-stream recycling in the Northeast, and since that point we've been learning every day. We saw a great opportunity to just do things better. About 18 months ago we started working with Van Dyke to start putting some of those ideas on paper. It's replete with redundancy, artificial intelligence, robotics, automation, optical sorters. This system will be a keystone for the entire recycling infrastructure for the Northeast.
A system like this going into Connecticut is the biggest system and the best system right now in the New England area.
New England's known for leading the way in academics, medicine, robotics, artificial intelligence. New England can lead the way in recycling as well. We want to make it really simple. Put recyclable material in your blue bin, and we got the rest.
So thank you for the time for that. I think that kind of gives you an overview of what we're doing in Berlin and how we plan on dealing with the single stream volume that we serve throughout Connecticut. So I think, I'd like to take this again from the consumer perspective of those that are, and when I say consumer, what I mean is kind of our customers, which for glass single stream recycling is really residents and municipalities. And I think important for this conversation here with lobbying teams and then also municipal representatives is realistically that's all of your constituents. So I think, as the company that really interfaces with all of these municipalities and residents, we bring a lot of firsthand knowledge of kind of what the consumer wants and expects. So I think the backdrop of this conversation is the challenges that we have faced around glass recycling and how do we handle it in the single stream. The first things first is we have to talk about where single stream is at in the state of Connecticut. And I think most of us have firsthand knowledge through our homes, bringing the blue bin to our curbside, because 98% of, and it may be more at this point, of towns in Connecticut have curbside collection, and most of those have single stream as the type of system that curbside collection recycling will use. If you remember back before single stream, we had a dual stream system where there was a little 32-gallon containers and then bundles of newspaper and cardboard that we would truck down to our curbside. A man or woman, multiple, would get out of their vehicles in that dual stream system, pump it with their back into different containers in our trucks, and bring them to facilities. I believe, and many in the industry believe, that the recycling movement, the watershed moment for recycling in the United States was the advent of single stream recycling. Has it come with challenges? Absolutely. But the increase in participation and the increase in volumes that we experienced through making the system simpler and more accessible to the consumers at the curbside has allowed us to increase the net recyclables that we're getting out of the residential waste stream drastically. We saw volumes in our own business double from dual stream days to single stream days. So when you hear arguments of increase in contamination, which I cannot argue that there is increased contamination with single stream versus dual stream, the sheer increase in the volume of recyclables is vastly outweighs the increase in contamination, but it puts the onus on companies like us to make sure that our equipment and facilities can handle that. I also, as I said before, the importance of our employees are really number one for us, and their safety is right at the top of the list of the things that we need to do as an employer in the state of Connecticut to follow through to our commitment to our employees. I'm not proud to say that the waste industry historically has been one of the most dangerous professions in the United States and globally. Since the advent of single stream recycling and increased automation, many of your curbside collections, I'm sure that you have in your hometowns, have automated side loaders that service your recyclables and MSW. Since we've moved to automation, and we were one of the first adopters of that technology, we've been able to greatly decrease the incidence of any injuries or deaths on the road by our drivers. We want to keep our drivers in the cab using an automated process as much as possible. That is by far the safest way to service any residential or commercial customers, and that's undeniable. So our commitment is to really move everything in our service area to an automated collection. So to focus back on glass, as I said, with the advent of single stream, it has created a challenge of how do we separate all these different commodities that come in one bundled package into different commodities and market them to end users such as urban mining. So to just focus on the glass side, I think it's important to say that realistically, if everybody did a fantastic job and everybody only put recyclables in the blue bin, it would be a much easier task. However, we need to be realistic, understand, and our team truly understands with decades of experience what this stream looks like, single stream looks like in the state of Connecticut. And that changes actually year to year, day to day sometimes. So we needed to develop a system and a facility that's able to handle those changes. And we believe we've done that through our expertise and the partnership with Van Dyke. This facility that we're building will be able to divert up to 40,000 tons of glass from disposal annually. That's a huge number. That's enough to handle all of the residential glass in the state. We worked hand in hand with urban mining to make sure that Van Dyke Recycling Solutions has the exact specifications that they'll need to make a product from our glass. We also worked with other end markets like Owens Corning and SMI to understand what their needs will be. We're confident that we're going to be able to serve all those end markets with our glass. So to take a moment now and talk about what are the most important elements of glass recycling. I think one of the biggest takeaways here is that for the single stream system and really any system that a town, municipality, residents choose to use, keep the garbage out of the glass. Doesn't matter if it's in a single stream process, drop off process, it's all the same. Keep the garbage out. What does that mean? What do we find in our glass for contamination? Pens, batteries, food scraps, shredded paper. All of those things are what cause us to have to do more work on the facility side to get those out to make a product that's usable for the end markets. I also would like to take a moment here and discuss some of the comments and things I've seen in the past around removing glass from the single stream. And quite frankly, a few years ago, hearing things that single stream may not be the right solution for a state like Connecticut. And I just, as a company and as somebody that deals with residents and municipalities on a daily basis, I really caution that approach. In the state of Connecticut, we have a well-established collection and processing system that can handle these materials. For 30 years, we've been insisting to consumers, again, our constituents, that recycling is the right thing to do, and glass in particular, in this case, should go in your single stream recycling. I caution that we go to these people now and say, throw all that out the window and don't put your glass in the single stream anymore. I'm here today to tell you we can handle it. These have been challenging materials in the past, but we don't shrink away from challenges here in Connecticut. We face them and come up with solutions. I think you're going to hear today from the others that we're able to do this in an efficient, cost-effective, and most important, simple way for the constituents in their single stream recycling, just as they do today. So again, consumer behavior is a big part of this, and to throw away 30 years of education of those consumers to put glass in recycling, I believe is a fool's errand. So in summary, I'd leave you with two thoughts. When it comes to glass recycling and really recycling in general, on the residential side and really any side, I look at it two ways: keep it simple and keep it safe. And that's where you're going to get the biggest bang for your buck. I mean, let's be honest. The people on this call here to discuss recycling in Connecticut and even on a smaller scope, glass recycling in Connecticut are not the majority of people in the state. We are the people that really value recycling. It's the first of mine. It's 8:30 in the morning on a Thursday. We're here to talk about it. That's not the average resident. The average resident absolutely values environmental sustainability and making the right decisions to help on a local level to make sure that we have a clean and green environment. But they want that to be simple for them. And we need to make sure that we are driven for solutions that are scalable, that are simple for the residents, simple for our constituents. And we are doing that through single stream recycling. And we are going to continue to invest in our facilities to ensure that we can get the most amount of recyclables in general, but in this case, glass, out of the waste streams, out of people's homes, and to end markets. So with that said, I probably went too long, but I will send it to the next presenter or any questions.
Thank you, Frank. Looking at a question here. In a few words, how could our EPR legislation, oh, that just went away. Sorry, the chat went away. How could EPR legislation be written to support or help your operation? I believe Jim, are we taking questions at the end? Let them think about this now, or should we address the questions at this point?
No, I would wait till the end for the questions, Lori.
Something to think about. Thank you. And we will go on to Ryan.
Okay, thanks, Lori. Hold on, I'm just trying to share my screen here. If I'm able to. It says disabled.
Should be all set now, Ryan.
Okay, great. Okay. Just a sec. There we go. Can everybody see my screen?
Yes, you're all set.
All set. All right, great. All right. Well, thanks, Frank, for that. It's kind of interesting. He mentioned a few things about, you know, evolution and changes we all make here in an industry. And our company was founded in 1984. Van Dyke Recycling Solutions. We're based out of Norwalk. All of our operations are located there. But in 1984, we started with Peter Van Dyke selling a baler into the New York market for commercial cardboard and high-grade papers. From there, we evolved into sorting more commercial single stream, just a hand pick line. We're pulling bottles off the line, trying to clean up that cardboard for end markets. Then we evolved into more of a dual stream type environment. We had 2 lines, one for fiber, one for containers. Glass is often included in that container line. And then we were pioneers in the single stream market and the evolution to single stream. So along that way, we hit a lot of challenges and have to jump a lot of hurdles to try and deal with the different changes that we have, both in packaging and with just education to the consumers. So for instance, over the years, glass has gotten a bad rap, and I'm going to get into that a little bit more. But I want to give an example for how companies like Murphy Road Recycling and ourselves, this onus is dropped on us, and recycling is a big thing for people out there today, especially in the Northeast and out West. And we've been able to deal with all those things. National Sword wasn't too long ago where we weren't able to move paper to China, and now we had to deal with domestic markets, and we found ways to work with that, clean up that paper, and you'll see that in the All-American MRF once it starts up, as we're building it right now. So a little more background, including changing for those markets. We've also made a test center so that we can develop tools right here in Norwalk, Connecticut for plastics recycling, fiber, flake sorting. You can see a picture of it there on the lower right. So that's an investment that we've made to the market. And then we've got a spare parts center here in Norwalk that supplies parts all over North America for our equipment for Bolograph, Lubo, and T-Tech. So just talking a little bit more about the role of glass in MRFs. Glass accepted, as Frank was saying, in most programs across the US and curbside programs, whether it's dual stream or single stream. And we've had to develop equipment to deal with that. So traditionally, like as I said before, it's viewed as a negative. And why was that? Well, it causes premature wear on sorting equipment. So if you're not taking glass out of the system and it runs through your entire system, you've got rubber skirting, you've got conveyor belts, you've got screening technology that wears prematurely and causes issues on the effectiveness and the efficiency of the equipment that's running. The second thing is that it's difficult to extract. How do you get glass when it's mixed in with all plastics and paper and other commodities? It's a sizing. And when you size 2" minus, not only do you get glass, you get bottle caps, you get shredded paper, you get all kinds of materials that shouldn't be there in the glass fraction. So we had to find ways to get that out and get all that contamination out of that fraction. The other issue with glass is if you don't get it out right away, it's going to get into your paper, it's going to get it into other commodities, and it's going to cause issues downstream for the marketability of those commodities. So as equipment vendors, we struggled for years to find solutions to make this happen. There's one other point I want to make too. End markets are critical. So when I go in and design a system, I need to know what my end market's going to be and what their specifications are going to be. Problems that we ran into in New England was that there was no end market. So then that gives another bad rap on glass, because where do you go with it if there's nowhere to go with it? If I don't know how to clean it or what I need to do or what specification I need to get to, I just can't do it. And then we have an issue. So it's great to hear companies like Urban Mining and others coming to light now. So we have somewhere to go with that glass. So we just have to accept that glass is there, that it's a recyclable product, and citizens in North America have grown to expect glass as part of their curbside program. So it wasn't going away, so we had to deal with it. So we had expertise in sorting fiber, sorting containers, but glass wasn't really in our expertise. So what we decided to do was to go to actual glass processing equipment in Europe and talk to those companies that are delivering material to Owens, are delivering material glass to glass. What did they do with glass and how did they clean it up? Because it's always going to be contaminated. So we worked with several companies, a company called Mogensen out of Germany in particular, where we traveled around, looked at what they were doing, brought that to North America and emulated their process here in New England and North America. We also learned other lessons along the way. So what's key at the bottom of this slide is material preparation to the glass cleanup system is critical. So what's the best way to get pure glass to the end of the system and out of the single stream? Number one, remove glass early. So one of my points before was that if glass runs through the whole system, you get premature wear on equipment and it's difficult for maintenance purposes. So the All-American MRF, we're removing glass right away. We're trying to get glass out of the system before it goes through, you know, the many conveyors that are there and all of the wearable equipment downstream. So right away, we take OCC out and we use a fine screen with steel shafts to break the glass, get it out of the system into our glass cleanup. The second thing is these screens aren't perfect. There are times that glass is going to run on top of paper. So we figure we get about 90% of that glass out right away. We've added a secondary glass removal further downstream to try to maximize and get 100% of that glass so it doesn't end up in the end and cause any contamination to other commodities. Thirdly, is we changed our screen design. So our screen design used to be these rotating, we call them flower discs, that had basically long holes in it. So things like a CD, flattened aluminum cans, we call them hockey pucks, a lot of long parts would drop through that type of screen, cause more contamination to the glass. So we've changed our screen type to be more of a square hole so that we don't lose that type of material, and it's more true glass getting to the glass cleanup system. So these are some of the things that we've implemented at the All-American MRF and I've learned over the years. So step one, what you get in a lot of these glass streams is you get oversized parts and you get long parts as well. So oversized material could be anything like just crumbled up piece of paper, that type of thing. That's pretty easy to take out if we do a primary screening with what you see on the right here, a combi screen. We remove that material. The other part that causes issues for Pat and his team over at Urban Mining is long parts. So a lot of straws, a lot of pens, toothbrushes can spear through the screen that I just showed you. This type of screen with the top deck could remove those long parts and get them out of the system right away. So that's key. That's number one. Step 1B is that this screen does another function and takes out superfine material. So that superfine material is shredded paper. So what a lot of people may not realize is they throw a bag of shredded paper, it gets ripped open in the truck, it gets ripped open on the tip floor, maybe a sorter up front on pre-sort rips the bag open. Now you have all this small, tiny shredded paper going through the system. That ultimately ends up with the glass, and that's compostable and causes issues with the glass. So a lot of that paper is less than a 1/4 inch, along with dirt and other contaminants. We remove all that 1/4 inch material out right away, up at the front of our glass cleanup system. So these pictures show an example of this type of screen. You can see the top deck and you can see the bottom deck in the blue here. So it's a multi-function screen. What we get in the end, our glass fraction ends up in the middle, at 1/4 inch to about 2 inch. So in that range, then we go to the next step of a glass cleanup system. So again, this is technology that we took out of Europe, and a lot of our equipment, you know, as Van Dyke, we're plant builders. So we take the best of the best, we put it all together in a package, design, deliver, install, and service. So the zigzag air separator is a product we saw at other glass facilities over in Europe. And basically what happens is your glass material drops into the top, you've got air blowing up and also sucking light material out. The heavy material, the denser material, falls to the bottom. So your glass fraction falls down. All the shredded paper I was talking about, bottle caps, really light, you know, less dense material goes up and out for residue. It leaves the system completely. And in the end, you end up with a nice glass product that the glass facilitators or glass processors can use to go to end market. You know, whether it's glass to glass or whether it's the concrete product that that Frank mentioned that Pat makes. So the other key here is wet versus dry. So we built systems in Texas with, you know, a pretty simple glass system. The glass looks beautiful because they don't get rain. It's very dry there. So light, heavy separation is pretty easy. In Canada, in the Northeast, you know, we deal with inclement weather. We have a lot of rain, a lot of snow, that type of thing. So that causes shredded paper to stick to glass, causes contamination, more contamination than the end market will handle or want to take from you. So this type of screen deals really well with wet material, as material is able to bounce in this chamber with a lot of air turbulence to get all that light material and all that organic type nasty stuff off of the glass, and then it becomes marketable. So in summary, just in picture, just to give you an idea, if to the left is what untreated 2-inch miners look like in the past. And I think you still see this in MRF some days. There's still some places that don't do anything with the glass, and then they call this landfill cover, or might just go to landfill completely. With the glass system that Murphy Road Recycling has invested in, you end up with a product like this. And it's not perfect because you still got CSPs, it's density separation, CSP being ceramic, stone, and porcelain. That material is still going to end up in there because it's the same density as glass. But there's other tools that companies like Urban Mining or Owens have to get rid of that material. What we're trying to do is prepare that material for those end markets so that they're happy with it and there is a place for it to go. Just a couple other notes before I wrap up. It's an investment. It's a capital investment for these companies to put in this equipment to clean up that glass. And that's what I think a lot of the avoidance is. It's a tough product because it's difficult to sell. It's not like a ton of cardboard where you get $200 for it. Glass is much more difficult to deal with. It takes capital investment, but if it's going to get recycled, that investment needs to be there. And that's something that Murphy Road has done and implemented the All-American MRF, and look forward for everybody to see it. I think that's about it, Lori.
Thank you. Very,
No
very
problem.
interesting. So next we'll move on to Patrick and hear from him.
Thank you.
I think Jim, you'll need to, he's on it right now. Perfect.
So, yeah, Jim, if you could share a screen here.
One sec. There you go, Patrick.
Okay. Okay, can everybody see that?
Yes.
Okay, thanks, Lori. Thanks to Jim and Lori for inviting me. Good morning, everyone. Good to be with you. Again, I'm Patrick Grasso, a partner at Urban Mining. And then today I was hoping maybe the time we have, I'll try and be as efficient as I can here with the presentation, just cover a few themes. One, just tell you a little bit more about the why putting glass in concrete, what it's all about and why it's so important. Maybe update you a bit since we were last in front of you back in, I guess, in May of last year. And maybe explain from a climate perspective why putting glass in concrete is the best use of glass, recycled glass we have today in the country. And not that all the other alternatives aren't good or great opportunities for glass, but this is the best from a climate perspective, and we'll get into that a little bit more as we go. So just broadly, just to explain to you what we're doing with glass in concrete, I think there's a misperception out there that concrete's a place just to bury glass. It's, if you don't have a better use for it, put it in asphalt, put it in concrete or whatever, but it's different. It's not just an inert aggregate that's used as it was in, asphalt or whatever. It's really, there's a chemical reaction that occurs here, making ground glass so small that it becomes a pozzolan. And, a pozzolan, just simply said, is a fine powder that by itself doesn't do anything. It's not cementitious, but when you mix it with water and cement, it becomes cementitious. In effect, a chemical reaction occurs that it creates more cement. That's why it's different than just using it, as a filler, as a sand, as an aggregate, anything else. It's actually, at this size, a chemical reaction occurs, and that's why it's exciting for its ability to replace the actual cement component in concrete. And pozzolans are essential to making stronger, high-performance concrete. And that's why it's so important to our DOTs around the country. And not to belabor the science part of this, but just for the science geeks in the group here, two things happen when you make concrete. The good stuff is made, calcium silicate hydroxide, which is basically the glue, the binder, if you will, of the concrete mix. The bad thing that occurs is calcium hydroxide is created. It has a deleterious effect on the concrete mix when that chemical reaction occurs. Glass, like fly ash and slag, that photograph above is a photograph of fly ash, another pozzolan, have a common feature. They all have a high silica content. As a pozzolan, glass gives up its silica atom to the CH, creates basically more calcium silicate hydroxide. So that's the magic that occurs. That's why it's not just an inert addition to concrete. It's helpful in making a stronger, better performing concrete. So I think it's important for people to understand that in terms of its significant benefits to concrete in our country. Those that have used it go back to the Greeks and Romans over 2,000 years. You can see those of you who travel through Europe have seen these structures still standing as a result of the good use of pozzolans back then. So just quickly to bring you all up to speed, because I guess we're in front of you back in May of last year. What's happened in our first year of operations? We went through a challenging year in the middle of COVID and all the related delays to commission our plants, re-engineer some parts along the way, rebuild certain parts, just to create this first of a kind plant anywhere in the country. We did some retrofitting to accommodate the HHRA pilot glass program. We expanded our feedstock storage area. We did a lot of product testing to make sure that we can create a high quality, consistent product for the marketplace, particularly in light of the wide range of feedstock that we've been taking. That photo in the right, by the way, shows finished block made by Westbrook Block here in Connecticut, shipped down to Carnegie Mellon as part of its program there. Some highlights for us last year. After a 2-year effort with Connecticut DOT, we finally got ground glass incorporated into its specs. In the last few weeks, that happened. That's a kind of a major shot in the arm now. Allows a lot of other users of concrete to feel more comfortable that state DOT and now has acknowledged its use. New York State, in the last few months, passed a low carbon concrete bill to encourage the use of products like Positive. We do hope Connecticut will follow in its footsteps to encourage the use of low carbon concrete in our state. Westbrook Block, as I mentioned before, probably Connecticut's largest block manufacturers, probably have produced over 500,000 blocks so far with Positive this past year. It's already in or scheduled to be in 100 projects with our partner ONG Industries, including some interesting high-profile projects like the New Canaan Library, the Oxford School, which is the rendering on the right, which is actually the entire superstructure is now built. We shipped 70 tons out as far as Arizona for a Microsoft project out there because they were so excited to test with it. Looking ahead, in this coming year, ONG, our partner, has really been a leader in using this product, now incorporating it in all of its 5 ready-mix plants here in Connecticut. The architectural engineering firm that's designing the West District Connecticut Deep headquarters plans on using the product to reduce the cement component of its concrete by up to 40%. That's an exciting new announcement in the last few weeks. It's going to be the new parking garage at Stamford. The town of Southbury has been doing some pilot testing with the sidewalks. I think Jennifer Heaton-Jones is going to use some product with one of its projects that she's undertaking now in her community. We've been specified in a very high-profile New York City headquarters project. Hopefully, we can announce in the coming months. But that's going to be I think a really exciting piece of news as well in terms of its use for this project. Kind of word is out. The dramatic climate impact, I think, is being better understood now, along with its performance benefits, and it's really being appreciated in the marketplace now that we've got the plant up and running and can produce at a commercial scale. It's getting some attention as we ramp up the business, particularly with the Connecticut DOT approval in hand. Other ready-mix producers are now much more engaged with us. With the new USA MRF coming online, it's cleaner glass. It's going to further enhance our throughput at our plant. So we're excited about that and hearing the news today. Ongoing testing is going on around us in neighboring states, New York, New Jersey Port Authority, Mass DOT are all doing significant testing with it, hopefully to further drive the demand for ground glass pozzolans. In prior conversations we've talked, and I think this group knows the challenges of glass in the past with MRFs, given the need to separate it, color segregation to get ceramics and porcelains out. No home for CRT panel glass, limited home for green glass. Most of it, as we know, still gets landfill. Making positive, we can use it all. When we grind it, it becomes a kind of a white powder. So we're color insensitive. We can take ceramics and porcelain. So that's a kind of a big benefit for our model versus other needs where it has to come out because of the temperature differential when it's melted to go back to bottles of fiberglass. So just broadly in terms of the size of the market that we're working within, our Connecticut and its neighboring New York and Massachusetts markets, use about over 4 million tons of cement a year. So if you replace just 10% of that, that's 400,000 tons of potential pozzolan demand right there. So it's a big market. We've been able to replace up to 40-50% of cement with positive. So it's a market that's not going away. Concrete, as you know, is critical. We use twice as much concrete than we do of steel, wood, and plastics combined. It makes a high performance product, long lasting, but there are significant environmental challenges with concrete, as many of you know. Again, if you make a ton of cement, you generate about a ton of CO2. That's really the big black eye for the cement industry. It's working on getting that down, but it's still a very significant number. The pozzolan industry, as we've talked about in the past, we're shutting down our coal burning power plants, converting to gas. So pozzolans have either been fly ash, which have been coming out of those coal burning power plants, or slag, which is mostly imported because we're not making much steel in the US. Both have their own environmental issues as well in terms of other chemical components within those fly ash and slag. And while those are becoming in more limited supply because we're making more high efficient steel plants and we're shutting down our coal burning power plants, the demand for that product is going up because in the past, while they're a post-industrial product, they have been helpful in reducing the carbon footprint of concrete. So there's a demand for that product as well in terms of this larger effort to reduce the carbon footprint there of concrete and cement. Again, very broadly, the dual benefits of the product, environmental and performance. On the environmental side, we've talked about the carbon issue. We can take all the glass, none of it needs to go to landfill. It makes a whiter, brighter product. This photograph on the right, you can see the top has positive in it. These are two city blocks of sidewalks we did in New York City with the New York City DOT. In our urban areas, it helps reduce the heat island effect, which is an important component in our cities. We make it from used and from regionally harvested glass. We use it in our communities. We minimize long haul transportation. On the performance side, the right side, you see what happens when concrete fails, when moisture gets in there, when salts get into concrete. It basically, and I've got some slides here. I won't take too much time because of our limited time today, but it basically creates a better performing, longer lasting concrete. It prevents the bleeding, the white powder you're seeing coming out of concrete sometimes. It uses less water, which means a stronger concrete. But the big thing it does, it reduces chloride penetration. The bad impact that our road salts have on our concrete. When salt and moisture get into our concrete, that photograph happens on the right. And that's why our state DOTs are excited about having a better pozzolan to use. This graphic just gives you a sense from a climate perspective, the impact that cement has on a concrete mix. The left pie chart shows you that cement only makes up 10 to 15% of concrete, but the middle one shows you that it accounts for about 80% of its carbon footprint. That's why replacing cement in the concrete mix is so important to get that footprint down. The right graphic just shows that cement overall globally generates about 7% of the CO2 that we generate every year. Climate Earth independent firm did an assessment of the production of positive and came up with an estimate that it's just 5% of the footprint of the Portland cement that it replaces. So it's almost a ton for ton savings in carbon by using positive versus cement in a mix. Our little plant here in Connecticut is the equivalent when it's fully stabilized about taking 10,000 cars off the road. This is an interesting slide. This was given to us by the Oregon Department of Environmental Quality, which is the equivalent of RDEEP. They did an assessment to show that by far the best use of glass is to put it in concrete, to use it as a pozzolan. Not that other alternatives aren't good. The top shows the production of making putting it back into new production, but because cement has such a big carbon footprint, replacing it with glass is by far the best solution, by far, as you can see in this graph. Matter of fact, Oregon argues that it's better. Actually, it's even better than cleaning, sterilizing the glass and putting the glass back in production without melting it. But I thought this was a good third-party validation of the argument we've been making, why it is the best place to be putting glass today. I'm going to go quickly through these slides because we're limited on time, but it just makes a point. This makes the point that using a ground glass positive is 5 times greater in reducing the penetration of salts and chlorides into concrete than just using a straight cement mix in that concrete. These just show that it performs as well or better than cement alone or fly ash or slag. This suggests it's the best performance to minimize shrinkage, which creates cracks in cement. This one suggests it is the best in terms of performance here. You want to be high on the graph. You can see 40% glass here at the top. In a freeze thaw cycles, 1,000 cycles that CCNY has done to protect concrete. There's been noise in the marketplace. Well, you can't use glass in concrete because it creates something called alkali silica reaction, a gel that forms that caused bad effects in concrete. That's the case when you use it as an aggregate, and that's why we're out there constantly telling people you cannot use it as an aggregate in concrete. It has to be ground to a fine micron-sized particle where it creates this chemical reaction, and it actually reduces ASR when it's used in a mix. Places where it can be used, and it is being used today, poured-in-place concrete. The plank you see here in the bottom photo, that top photo is a recent pour. We did a major slab. It's in pavers. We'll give you a few more examples here as we go. But there's really no place where you use concrete that you can't use a ground glass pozzolan. Some examples of where it is in plank and finished brick. First high-rise pour in the bottom right-hand corner with the Durst organization in New York City. Very exciting landmark installation for us. It's in the pavers outside the UN. Sidewalks as far as Google in New York City and elsewhere. As I mentioned, a few projects here in Connecticut as well. Westbrook Block, that's their plan here in Connecticut. Their quote from their website. It's basically helping them create a stronger, more denser CMU with a lower permeability than the industry standard, than the ASTM standards that are out there right now. So the applications here in Connecticut, ESPN's headquarters, residential project in Stamford, the Oxford School we talked about, UConn's facility here in Connecticut. Some photos of our plant. Some of you have been there to see it. Those of you who have not are welcome. Let me know if you'd like a tour. We're happy to take you through. And just quickly to kind of wrap up, I think we've got the solution, large scale solution for MRF Glass, and a home for all the wine and spirits bottles that are in discussion right now. We're excited about the opportunity to work with USA and their glass. We think it's going to be great glass to work with, given the efforts they've put in it to clean it. We've got a real alternative to the costly and diminishing landfill options that the Northeast faces. It's a truly a new and exciting, commercially viable, low carbon solution for concrete, and it's making a better performing and longer lasting concrete. And again, it's a great environmental story for all of us to be telling our communities, the feedstock being sourced locally, the finished products being manufactured and used locally. We're creating new jobs, and we've got more to come as we ramp up. We're confident we've got the solution for MRF Glass in our state. We just asked, we'll be given the chance now to kind of prove it as we ramp up our business in the coming year or so. So thank you. I maybe rushed through that a bit, but I wanted to keep us on schedule for 9:30, and I think I'll pass the mic back. Thank you.
Thank you, Patrick. Wow, this was for me personally extremely informative. Hearing about all of these advances over the years and having this final product for you, taking the material, taking us through the process this morning. I know we're on a time schedule, so I'll turn it over to Jim for some questions if he wants to go through them. And I'll leave it up to Jim with the time frame. I can run over. I'm not sure who can.
Well, we have 3 questions in the chat, so let's try to get at these 3 anyway.
Great.
The first is for all the panelists, the EPR legislation, which was the subject of the last 2 seminars, could it be written to help or support your operations? That's probably primarily at Frank.
Yeah, I'm happy. Actually, I welcome the question. I think it's an important one. So we've researched EPR quite a bit. We've had EPR for hard to handle materials in the state of Connecticut here for mattresses and paint. We believe that there is a place for EPR for hard to handle materials or dangerous materials for that matter. And that's where we really think the opportunity is for an EPR discussion. Where we've seen EPR for products like packaging or glass and single stream materials are really in places where the infrastructure doesn't exist to be able to collect and process the materials. That just simply isn't the case in Connecticut. As we spoke about, there's pretty much universal access to a curbside collection program. It already exists, and there's access also to the available MRF capacity to process all of those recyclables. So we believe that EPR for products like glass and other packaging really would just add to complexity of the whole process.
I'm listening.
May add costs, and I think the most alarming part of that is we've also seen in those areas, mainly where they have these EPR for packaging, there's been a decrease in innovation. And I think that's an alarming kind of.
You'll text it to me? Because I'll be in the PR.
As you've seen today, local companies here in Connecticut have solved the issue around glass or are working to solve that issue. And, I would be hesitant to think that, or I'd be cautious hearing what we're hearing out of Canada with the lack of innovation and decrease in innovation of those programs, that maybe that this kind of a situation would not happen under one of those programs. I think, so if you say, what can it do to help? I think the 3 companies that presented today say, we really don't need the help. I think we're on the path by ourselves, and I think that may be the quickest way to the solution.
Patrick, how much is the unit price premium for your customers over current alternative materials for cement?
Patrick,
There we go. Okay, now I'm off mute. Okay, thank you.
perfect.
That's a good question. Thank you. The good news is there is no premium. We're actually under, given where some prices have moved right now, cement, fly ash, and slag. So, no, there's no premium. You know, we're at a stage now of just kind of a learning process, educating the marketplace of the benefits of this. But from a cost perspective, there's no premium at all.
Great. Again, for Frank, it looks like a shredded paper hasn't been acceptable in Connecticut's mixed recycling program since 2017. How much shredded paper does Murphy Road /AMH/USA get? Is it still a big issue?
Yeah, it really is. I think, you know, it's an education issue that we really need to pour into, that people see it as paper goes in the recycling, and therefore they put it there. It's wish cycling, and it definitely needs to be addressed. Still an issue.
Final question. How will the investment in capital impact tip fees to municipalities?
Yeah, I think another great question. Listen, we operate in a very capital intensive business. It's what we do. Every year, I mean, we pride ourselves, we run the newest fleet on the street. This is part of our business model. And quite frankly, we believe that the added capital investment over the long term will keep pricing down on our operational costs, and therefore municipalities will enjoy the long-term benefits of reinvesting in our capital to make sure that they have a resilient and reliable solution for their recycling at a very at a great value. So we think that we're going to be able to drive down costs on the long term, or at least stabilize them, and create products that are more marketable, and therefore the municipalities have the ability to enjoy the benefits of a more marketable recycling product.
For Patrick, has pozzolan ever been incorporated into materials that allow for permeability to decrease water runoff?
Yes. It's kind of, yes, and it's separate than the issue of its ability to, the good news, it blocks permeability for, you know, and chloride, as we talked about, but depending on how the block is manufactured, if it's made to be a porous block, yes, it can be used. So it's how the block is manufactured, or the concrete is manufactured, rather than this, you know, as I mentioned earlier, it's strong suit, which is its ability to block moisture and chloride penetration. So it's really more in the construction of the block rather than the use of positive.
Great. Well, Lori, tossing it back to you for the close.
Perfect. Thank you. Thank you, each and every one of you, for attending, and our panelists for discussing this topic. Very informative. As a reminder, next week, week 4, will be our final presentation. Same time, same day. Please consider signing up. We'll hear about expanded polystyrene. And again, of course, we have to put the plug for consider becoming a member of CRC with additional memberships and reduced fees for our June, hopefully, in-person session wrap up. So have a good day, everyone, and we'll see you next Thursday.
Thank you.
Thank you.